Hi, my name is Abe and I'm going to show you how to differentiate exponential functions and log functions in this session. So remembering that differentiating is simply just finding the gradient function, so a function that shows what the gradient is at any point of these functions. So what I'm going to do is I'm going to start by drawing the two functions that we're going to look at today. So the first one, exponentials look like this. So e to the ax plus b, right? And what do they look like? Look like that. Flat down the bottom, and it goes up very, very rapidly. Okay, so you expect the gradient function to be doing something like this. The gradient function should be quite small initially, but then the gradient will increase very, very fast, just like the function increases very, very fast, right? So let's see if this is the case. From rules, we see that this is the case. Derivative of e to the ax plus b is equal to a times e to the ax plus b. So it looks very simple. Not much changes actually, but this fits with what we understand. Look at this function here, a times e to the ax plus b. That's just the same function almost, except multiplied by something. And so we see that this derivative function also starts out very, very softly, very gently when x is small or when x is negative, but this is also going to shoot up very, very quickly, right? Okay, so that's the first function we look at. The second function we want to look at is the log function. So let me draw that too. It's going to look like this. Log function does this. So this is f of x is log to the base e ax plus b. Simple. And the rule for this, the derivative of log to the base e of x plus b is a on ax plus b, and a small condition on x bigger than negative b on a, because the inside, if you remember, of the log function, this part has to be bigger than 0, because the log function is normally only defined for values bigger than 0, and so to fulfill that you need x bigger than negative b on a. So outside of that range the function doesn't exist, and so the derivative doesn't exist. Cool. It's very good. Although I want to show you one more thing. Sometimes you'll see this. Sometimes you're going to see derivative of log to the base e and then absolute value ax plus b, like so. Now before I show you what the derivative of that is, I'm going to draw the graph. So this graph is really simple. It's kind of like saying, well, I'm going to just make every value inside here positive, period. So really you just get a reflection over here. Graph does this. So this bottom function, it's actually the red graph, and I'm going to draw over the blue one to show that the red one covers both, like so. And in both cases there's this asymptote in the middle, because you can't get the inside of a log equaling 0. And so the formula for this one, again, is not particularly difficult. It is actually the same. A on ax plus b. But the only difference is that here x is allowed to be any value except for the value that makes the inside of the log 0. And so x is just simply not allowed to be negative b on a. It can be anything else though. That's cool. Very easy. So very quickly, let's just do a couple of examples. So for the exponential side, let's find the derivative of 2e 5 on 2x plus 2. Sorry, this part here is all in the power. So this is what we would do. You use your rule, so the 2 stays out the front, times. Now a in this case is 5 on 2. So you'd bring a to the front, and you'd keep the power on the e exactly the same. So it's simply 5e 5 on 2 x plus 2. Simple, right? All of this is the power. Okay, onto the log side. Let's give this a go. Let's find the derivative of log to the base e of 5x minus 7. This is simple. Again, just look at the formula. In this case, a is 5, b is negative 7. And so that's simply going to be 5 over 5x minus 7. And remembering to put the limits in, not the limit, but the restrictions on x, x must be bigger than negative b on a. Negative b is 7, a is 5. Because this function here is only a one-sided function, right? So it's more like the blue function we have here, where it's only defined for one side. So yeah, there you go. There you have it. Exponentials and logs, easily differentiated. Hope you had a good time. I'll see you next time.